Okay, this is a recording for the Unit 6 test review. Problem number 1 will talk about a dilation with a non-origin center. Be prepared to look at it as a contraction, or it could be possibly an expansion, and it could look something like this. In fact, it will look like something like this. It says graph the image of the figure after a dilation with a scale factor of 1/4 and centered at 6 and -4. So they will give you an image, a pre-image, and they'll want you to graph it. And so with a non-origin center, now when I mean non-origin center, I mean it's not at 0 and 0. It's down here at 6 and -4. So this is what I like to do. What I like to do is, and just to illustrate the point here, I like to kind of draw a line, but using just vertical or horizontal lines from the center of dilation to one of the vertices. And then what I do is I count and that distance 1, 2, 3, 4, 5, 6, 7, 8. So that has a distance of 8. This has a distance of 1, 2, 3, 4, 5, 6, 7, 8 as well. So what you do is you multiply those distances by the scale factor. Okay, so you go 8 times 1/4 and 8 times 1/4, and what you end up with is 2 and 2. Okay, so what we do now is we go from this center of dilation, you go over 1, 2, that distance, and then from there you go up 2. And right there is this point's transform point. There, I can't think of the word. There you go. So let's choose a different color. 1, 2, right there. Okay, and if you were to notice, you could totally see that if I were to draw a straight line, those would match up nicely. See that? Okay, so let's go ahead and erase these right here. Kind of give us a clean slate. All right, now let's try this again, but let's do this with, go here to the next vertice point. And again, let's go ahead. We know that this guy here is 8, right? And we know that this guy here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12. So again, we're going to multiply each one of those by the scale factor. And you get 2 and you get 3. So what we're going to do is go from the center of dilation and count over 1, 2, and up 1, 2, 3. Ooh, this is going to be an itty-bitty image, isn't it? So, all right, let's do this. We got one more point. Erase this stuff right here. Okay. And you've probably guessed already where this is, but look at that. Oh, lovely. All right, we know that has a distance of 12. So 12 times 1/4 is 3. 3. So 1, 2, 3. There we go. So there is our image. Pretty cool. And like I said, if we wanted to draw lines now, we could really see from the center of dilation through the corresponding vertices, we could totally see that they match up. See that? Pretty cool. You won't need to do that on the test, but you can see that here. Okay, so be prepared for a contraction or an expansion. Expansion works exactly the same way. You just multiply the distances by that scale factor. Okay, the next question, it says the length of XY is 8 units. So they're just giving you a line segment like so. It's pretty simple. They're telling you that it's 8 units, so this is XY. What you do is you take that length. It says, well, let's read the directions complete, right? What is the length of the image of the line segment after a dilation with a scale factor of 8/3? Really quite simple. All you need to do is take that 8 and multiply it by 8/3. And what we end up getting is 64/3, which is close to 21 1/3. So it really expands that greatly, doesn't it? Yeah. So that's pretty cool. 64/3. And I think on the test they want just the improper fraction. Okay. Negative scale factors. So negative scale factors, and we've talked about these quite a bit in class, they look something like this. Okay. Notice on this dilation here that we didn't have a negative scale factor, and notice that the image and the pre-image are on the same side of the center of dilation. But as we look at our negative scale factors, they're going to be on the opposite side of the center of dilation, and you can totally see that. So let's read the directions here. It says the smaller triangle is the image of the larger triangle after dilation. The center of dilation is 4 and 2. So really all you do is you compare corresponding sides. This has a distance of 12, and the image has a distance of 4. Okay, 1, 2, 3, 4. Now remember, it's really important to understand that our scale factor is going to be the image divided by the pre-image. So you take corresponding sides and plug them in for the image and pre-image. So 12 divided by, actually, sorry, the smaller triangle is the image. So the smaller one is going to be 4 divided by 12. So that reduces down, of course, to 1/3. So just remember that if this is the image, and this here is the pre-image. If you guys need to, on the test, feel free to snip a problem like so. So I'll break up my snipping tool, and I'll click on new, and I'll snip it, and then I can draw directly on this. So if you need to make notes just like I did, then that will help you solve it, you know. Okay, just a little suggestion. Okay, expansion or contraction. So what they're going to do is they're going to give you a table of scale factors, and you're going to need to determine if they're an expansion or contraction. And we've had quite a bit of practice with this in Class Connect. So for instance, so if you remember, in class I would give you two little boxes here, and we would say, okay, and all right, I'll give you a scale factor here, such as -4. Well, -4 we know is an expansion, right? Even though it's negative, remember the scale factor, if it's an expansion, we know that the scale factor is going to be the absolute value of the scale factor. You guys get to see all of my writings here and misdoings that you don't get to see in class. All my little slip of the fingers and stuff. Let's see. So our absolute value of our scale factor is going to be, actually that's, what am I doing? Our scale factor is going to be greater than 1. Okay, so if it's a contraction, we know our scale factor is going to be between 0, our absolute value of our scale factor is going to be between 0 and 1. Okay, so for instance, what if they give us something like 0.25? Well, we know that 0.25 is a contraction. Okay, so be prepared for those. Be prepared to classify contraction or expansion. Okay, so one of the questions on the test is going to talk about what are the coordinates of the midpoint of the line segment with endpoints P, -5 and 6, and U, 4, -2. So this is really quite simple. We can do x1, y1, x2, y2, and you can see the midpoint formula up there on the screen right over here. So x1, y1, we're going to have -5 plus 4 divided by 2, okay? And our y is going to be 6 plus a -2 divided by 2. Okay, so we'll have -1 halves and 4 halves, which reduced is going to be, again, -1 half doesn't reduce anymore, but 4 halves does. It reduces down to 2. And that would be your midpoint. That's pretty slick, huh? Okay. Question number 6 is dealing with directed line segments. Okay, and so here is your directed line segment formula. It's really important that you guys know that. Okay, so let's say that we have 2 points that we want to find a directed line segment. Let's see what's okay. So let's say that we have a line here connecting these 2 points. Okay, like so. Okay, so obviously we have point. We'll call this point A. And we'll call this point B. Okay. All right, so point A is located at 1 and 4. And point B is located at 5 and 1. So let's say that we wanted to, we want to know the coordinates of the point. And let me just type this up on the board. What are the coordinates of the point that partitions the directed line segment AB in a let's say 2 to 3 ratio. Okay, so now oops, I forgot my little question mark there. That's not a sentence, that is a question. Okay, I guess it is. Anyway, what are the coordinates of the point that partitions the line segment? So if I were to take an imaginary, just kind of eyeball this, in a 2 to 3 ratio, that means we're going to divide this up into 1, 2, 3, 4, 5 sections right here. See that 1, 2, 3, 4, 5. And we want to know, since we are going from A to B and we want a 2 to 3 ratio, that means we want, and I'll go ahead and mark this in a little more distinct way. We want this guy right here. Okay, that's supposed to be a star, but it's not. But anyway, so what we're going to do, we know that M is 2 and N is 3. So now we have enough information to solve this. Now remember, since A is our first point, then it is going to be x1, y1. And we know that's our first point because of the very name right here, AB. And then B is x2, y2. So we go ahead and plug these in. We know that x is going to equal, now use this formula right here, 2 times x2, which is 3, no, which is 5. Can't read it because of my handwriting. 5 plus n, which is 3, times x1, which is 1, divided by m plus n, which is 5. And then our y is going to be, and it's exactly the same as this guy, except we're going to replace the x1 and x2. So it's going to be 2 times y2, which is 1, plus 3 times y1, which is 4, divided by 5. Okay, so then we're going to have 10 plus 3, and this isn't going to work out as evenly as I want to, but that's okay. 10 plus 3 and fifths, and then 2 plus 12 fifths. And so our coordinates are going to be 13 fifths and 14 fifths, which if you think about it, 13 divided by 5, right? That's about, so we're going to be about 2 and 3/5 of the way. So 2 and 3/5, about there. And 14/5, of course, is almost, it's almost 15 divided by 5, which is almost 3. So right there, oh, I eyeballed that pretty good. So hopefully that helps with the directed line segments. Okay, question number 7 on the test. We're going to be dealing with similar polygons. Okay, and so our similar polygons, they're going to give us, they're going to give you 3 different polygons, like so. Okay, and they're going to say, well, let's say that this side is 80 and this side down here is 20. Okay, and then we know this side right here is 20 and this side down here is 5. And then we know that this guy over here is 60 and this guy over here is 20. And they'll say, well, they'll give these polygons a name A, B, C, and they want you to know, they want to know which ones are similar. Well, what we can do is we can take, for instance, their corresponding sides and divide them. Okay, so for instance, this is 80 divided by 20. This guy here will be 20 divided by 5. And then make sure the sides are corresponding. You can't just do any random side. And this is 60 divided by 20. Okay, so 80 divided by 20 is 4. 20 divided by 5 is 4. And 60 divided by 20 is 3. Oh, that's a problem. We know that A and B are going to be similar because they have the same scale factor. And we have, oh, and by the way, these are not just any random polygon. These are rectangles, and they'll tell you, they'll say these are rectangles. And 60 divided by 20 is 3. So we know that A and B are similar, but B and C are not similar, and A and C are not similar as well. Okay, so the next question on the test is going to deal with whether or not you can understand a similarity statement. And similarity statements are going to be very, very, very similar to congruent statements. So what you want to look at here is if we have triangle, let's say, oh, I know, let's say XYZ. And they tell us that triangle XYZ is similar to triangle RST. Okay, you've got to determine which parts are congruent to which parts. I mean, similar to which parts. Okay, so for instance, now remember, angles are going to be congruent even though they're similar triangles, right? We talked about this. So we know that angle X, for instance, is congruent to angle R. But segments like YZ and ST, they will be similar. Okay, so for instance, YZ will be similar to ST. Okay, if you're not kind of catching the vision here, let me go ahead and draw up a couple of triangles. Okay, so here is triangle XYZ. Okay, and they tell us that triangle XYZ is similar to triangle RST. Okay, let me go ahead and label these. So X, Y, Z, and R, S, T. We can see that YZ is similar to ST. Okay, and you can see that in the name, right? YZST, and you should be able to see it in the name. If you can't see that in the name, then something's wrong. Okay, and then we can see that angle X is congruent to angle R. So remember, even though they're similar triangles, the angles are still congruent. So make sure you understand that for the test and how to read those similarity statements. Okay. Actually 2 questions on the test will deal with just that. So be prepared for that. Okay. So the next thing that they are going to talk about is corresponding parts of similar triangles. So for instance, we can see that, for instance, EF is going to correspond with RQ. Okay, so what they'll give you are 2 triangles, and you have to write the similarity statement, I should say. So we know that EF corresponds with QR, right? So if it helps, we can draw, well, EFD is similar to triangle, so E, let me break out the highlighter, I think that helps. E corresponds with Q. See that? I think that's the better way to teach that. F corresponds with R, and D corresponds with P. Okay, so EFD, so EFD corresponds with Q, R, P, and it needs to be in that order. It's really important that the corresponding parts are in the right order, because we need to see this from the name. We need to see that angle Q corresponds with angle E corresponds with angle Q, angle F corresponds with angle R, and angle D corresponds with angle P. So be prepared to do that on the test as well. Okay, so remember how we talked about triangles. If we have similar triangles, that their angles are still congruent. Okay, so let's say that we have, let's label these triangles here. Let's say A, B, C, quite original, right? A, B, C. And corresponds with D, E, F. Okay. All right. So we know that triangle ABC, oh my heavens, don't you love that? Triangle ABC is similar to triangle DEF. Okay. So let's say that they tell me that the measure of angle A equals, let's say, 50 degrees. Okay. Love that. So the measure of angle A equals 50 degrees. Okay. And then they tell me that the measure of angle F is 40 degrees. Let's say it's 45 degrees. Okay. Then they want me to say, well, what is the measure of angle B? They want me to find the measure of angle B. Okay, so this guy right here. So what I would do, if I were you guys, they probably won't draw these triangles out for you. You're going to need, if I were you, I would draw these triangles out. I guess that's what I'm trying to say. So the measure of angle A is 50 degrees, and it gives us a nice visualization of what's happening here. Measure of angle F is 45 degrees. Well, because we know what we know that angle C and angle F correspond, and we also know that measure of angle C does equal the measure of angle F. So that if that's 45 degrees, then I can use triangle sum theorem to figure out what the measure of angle B is. And so we know it's going to be 85 degrees. Even though it doesn't look like it, doesn't matter, but it gets the point across. Okay, let's double check that. 50 plus 45 plus 85, because I was doing mental math. And yep, 85 degrees. Perfect. Yeah, so make sure you know that all of these angles add up to 180 degrees. That should be almost second nature to you by now. Okay. Last question on the test is going to be dealing with scale factor of similar polygons. So let's say that we have two polygons here. And let's say they're two rectangles, more specifically. Okay? And they tell us, hey, first of all, they say, well, this is polygon rectangle ABCD. And they tell us that that is similar to EFGH. Okay? So we know that ABCD is similar to EFGH. And they also tell us that they are rectangles too. Okay. We'll just write rectangles in front here. And because they're rectangles, we know a whole bunch about them already, right? So let's say that this that AB is 9 and BC is 12. And EF is 3 and FG is 4. Okay. What is the scale factor if the dilation is from ABCD to EFGH? So what they're going to ask here is, what is the scale factor of a dilation from ABCD to EFGH? Okay, so that's really important to know, because now I know that ABCD is my pre-image, and I know that EFGH is my image. Now remember, our scale factor is going to be based on, is going to be our image, just one of our corresponding sides, divided by our pre-image, if you remember that. And hold on, I'll give you the division sign here in a second. Ooh, we can't have non-matching division signs. Okay, so there we go. Image divided by our pre-image. So what I'm going to do here is I'm going to take my, let's just say I'm going to take EF, and that corresponds with AB, right? So my image is going to be 3 and my pre-image is going to be 9. And so reduce that down and we get 1/3. Okay, so be prepared. This could be, obviously this is a contraction, right? It's going from big to small, but it could also be an expansion. So be prepared for that. Just make sure you know that it's the image divided by the pre-image, the corresponding sides. And you just need one side. It doesn't matter which side you choose, because what's 4 divided by 12? Well, it's 1/3. Same thing, right? All right, well, that's all, and I hope this helps and get you prepared for the Unit 6 test.